So we all saw the importance of prompt engineering in generating a proper detailed image. Now let's do a hands-on on the same. As you can see on the screen, in order to proceed with this lab, we need certain requirements. Let's look at these requirements. You need these libraries along with Python 3.12 installed in your virtual environment. How do you do that? You have this requirements.txt file where you have the list of libraries and you have a setup file. This setup file will make it easy for you to install all of these requirements along with other dependencies, including setting up your Hugging Face account and also setting up Git LFS as needed. Starting off, this will install Python 3.12, which is important for this particular hands-on. Other versions of Python may not work properly with these specific libraries. After that, you need to log into Hugging Face and set your Hugging Face token using this setup file, and it will install all of the requirements file. It will install some extra required libraries that are not there in requirements. It will log into Hugging Face and get everything ready. Now that you're done with the setup, let's go back to the code and understand how we can work on prompt engineering. Starting off, we're importing the necessary libraries. For example, config parser, which will read the values from config. We have llama CPP, which is a CPython library that can load LLMs in quantized format at a much higher speed, that is much more tokens per second. So when you interact with the large language model, it is going to be much faster compared to traditional transformers library or with any other library. You also have LangChain core prompts. So this is for formatting the prompt. You may or may not need it depending on which model you use and how you plan to use it. We'll look at these details as we go forward. First, we load the config. What are the details that we need to save in the config that are needed first? So let's take a look at the config that is needed in order to save our values and use them in these variables. What are the values that we save in the config? First, we need to download a large language model and save it in a path, which will be mentioned in the config. This is necessary for the prompt engineering step, where the large language model should be sufficient enough to do the prompt engineering, but at the same time, it should be able to load in the necessary VRAM that you have. In this particular case, we have chosen Qwen 2 7.5 billion parameters instruction fine-tuned model. The reason behind choosing this model is that this specific version of the model that is instruction fine-tuned works really well on a host of topics, especially in describing them and elaborating on them in detail. This is quite helpful for prompt engineering, as no matter what kind of prompt you enter, be it a smaller one, be it a detailed one, it will always be able to handle those topics and create a more detailed prompt that can generate a better image. Then we are defining all of the other things like the output directory where you're going to store the image outputs. We have many other things saved here. What are the things that we need for prompt engineering here? In prompt engineering, we are taking the model. We have the context length, the batch size, the maximum tokens, and the temperature. Let's understand how to set these values so that your project can work really well depending on your use case. When it comes to the context length is quite helpful when you're having a longer chat history. For example, if you're talking to, let's say, a chatbot, and you have a series of conversations, the longer your context length, the more easier it is to remember your entire conversation and respond back to you. We'll go through in detail as to where context length is helpful in our use case as we move forward. Meanwhile, let's look at the other variables. The batch size, this is for determining how many inputs you can feed into the LLM at one go. So for example, if you're deploying this, which we'll see later on, in a way that it needs to process multiple inputs at the same time, this will work really well and generate you multiple images. Maximum tokens, this determines how longer you're willing to go, how bigger you're willing to go with your prompt. If you want your prompt to be much smaller, you can limit this and it will generate maximum tokens of a much lower length. So your output prompt will be of less words. So we also have the temperature. What's the temperature? The temperature value between 0 and 1 is responsible for how strongly your image is generated close to your prompt or how creative it is. For example, you want to generate the image of a cat and you have given it some instructions what it looks like, what the background looks like. Now, if you set a very high temperature close to 1, the engineered prompt is going to be quite creative. It will add a lot of new details that you did not add and make it really nice. So if that's what you want, or if let's say you want to generate some artwork, then it's quite helpful to have a very high temperature that will add a lot of creativity to your image. At the same time, if you want to generate something very specific, let's say the image of a tool or the image of a product, where you want it to follow exactly your instructions, that way you can set a very low temperature and your engineered prompt is going to follow closely exactly what you described. Hence, the image of the product or the tool or any other item that you're generating is going to be quite identical to exactly what you described. So this is the difference between setting a low and high temperature. Going forward, we are loading the model files. Talking about Llama CPP and how this model works, I mentioned the model is Qwen 2.5 billion. Now, if you want to run your model on a CPU, or you have low VRAM, be it you're running on a GPU or be it you're running on a CPU or any other kind of system, let's say a TPU, you can use Llama CPP independent of the platform and load your model, and it will still work at a decent speed. The way this works is mainly two ways. Llama CPP is a C Python library which is quite fast because of it being written in C++, and at the same time the model is quantized. In this particular case, the model is quantized to Q5km. Hence, the amount of memory required for this is significantly less compared to the original model 7 billion. For example, 7 billion will require around 20 GBs of VRAM or CPU memory, depending on how you're running it, along with some extra buffer memory for storing the prompt and answering your questions and generating the engineered prompt. When you're doing it with a quantized model, let's say for example Q5km in this case, this will require only around 4 GBs of VRAM and let's say an extra additional 1 GB, so total 5 GBs of VRAM or CPU RAM to generate it. Hence, if you are working with a system which has these limitations, you can still get the result in a pretty fast, with a pretty fast response, and at the same time you won't have issues with memory out of error. So this is the use of Llama CPP and a quantized model, and you can see on the screen that we are loading the GGUF format quantized model. It is in two parts because it's a 7 billion model, so it's quite small. There's only two parts, and we are specifying the first part which follows a specific pattern. This will automatically take the next pattern, and likewise it will load the model. Let's look at the next steps. We have a function defined for loading the config. This is taken from config parser and it's reading from the config file that we saw on the screen. Then we are loading the model, which I have stored it in this particular folder, and we are giving it those values that we read from the config. That is the context length, batch size, and another attribute verbose, which basically if you set it to true, then you will get to see all the inner workings of Llama CPP, how it is loading, if there is any issue you want to debug. Otherwise, you set it to false. Now, we start with the actual instructions for prompt engineering. Into this template, we'll be passing what we enter. So let's look at this in more details. First of all, we are getting the basic details like max tokens, temperature. Then we're defining the prompt. If you see, there are a lot of specific tokens that have been mentioned, and inside that is nestled the user prompt. The reason behind this is that depending on how you use your model, whether with Llama CPP or whether with the transformers directly, you can load the prompt in different manners. You can use the auto models. You can use the auto modules from transformers to automatically load the prompt and format it in the specific format for that large language model. Or you can use Llama CPP and you can specify these tags which are specific to Qwen. If you use a different model, these tags will differ. So you need to check up in case you're using a different model. For example, let's say Llama 3. Now, we have the user prompt in here, and you have given these instructions like you're a helpful assistant and an expert prompt engineer for AI image generation. Your task is to rewrite the user's prompt to be more detailed, vivid, and creative, specifying style, lighting, composition, and any relevant detail for a text-to-image model. Thus, we are giving these instructions so that it can focus on these aspects of it and expand on the prompt. After this, the assistant will start responding. So if you see the prompt, it ends with I am start assistant. So after this, whatever response is coming from the LLM, and that is how it will be streamed. So we have the stream function here. We have the stream object here which will be run. So we are loading the prompt, the max tokens, temperature, and you have set stream equal to true. What is stream? So in the context of using Llama CPP, just like when you're using a chatbot online and you type something and it does not wait for the entire text to be generated, it keeps streaming the response. That's the same thing happening here, and it's being done with Llama CPP. You can choose to turn it off in case you want the entire prompt at one go, depending on your use case. Now, we go to the next part, which is basically running the model. We have everything ready, our prompt, all the variables that we need, all the attributes that we need, and we are going to run the model and input certain value, certain details about the image that we want to generate, and it will engineer the prompt and give me a more detailed prompt. Let's take a look at that. So I have the terminal ready. Let's say I'll generate the image of a biscuit packet on a table, a very simple prompt with no detail. Let's see what the prompt engineer does, and we'll be able to see it almost instantly with Llama CPP, because as I said, Llama CPP is a C Python library loading quantized models, so it's quite fast. And we see the streamed prompt here. I'll read this. A close-up image of a beautifully designed biscuit packet sitting on a rustic wooden table in a cozy kitchen. The biscuit packet features a vibrant, pastel-colored illustration of whimsical fairies and flowers with golden highlights accentuating the text and the design element. The table has a warm, amber lighting with soft shadows, casting a gentle glow on the biscuit packet, which is partially illuminated, creating a sense of depth and texture. The background is a blurred, muted color to draw attention to the biscuit packet, and the table surface has subtle crumbs and tea stains to enhance the realism and coziness of the scene. So as you can see, this is a really well-crafted, detailed prompt, which is very ideal for advertisement banners. So let's say you are a part of a company that is working in the advertisement field and you want to sell a packet of biscuits and you want to create a banner for it. You no longer need some kind of a detailed team that is working on these details and then crafting and editing these details. You can simply use AI to craft this prompt and proceed with the image generation. So that's the importance of prompt engineering, and after this we'll move to the image generation step.